Alright guys, welcome to our study guide for the Unit 12 test. I'm just going to go through a bunch of different problems, and all these problems have all the strategies that we've talked about in the past 3 lessons. And so, just take as many notes as you can. I'll show you guys how you should be showing your work and how you should be writing your explanations for each one. Alright, so let's begin here. For number 1, the first thing I would do is change everything to sine and cosine. So I would change the secant x into 1 over cosine x. I would leave that sine x just the way it is. And then I would change the tangent x into sine x over cosine x. And we do have to put our reason for that. The way I got from here to here then is by changing to cos or sin. Okay? Next, we're going to simplify on this side by multiplication. And so we end up with sine x over cosine x equals sine x over cosine x. And we got there by multiplication. You could also just say simplification. But in any event, we're done because we got the two sides to be the same and we've successfully completed our proof. Okay? So let's go ahead and move on to another one, number 2. So for each one of these problems in the study guide, I would encourage you guys to think before me about what maybe you would do. And just because I do something different than you doesn't mean you're necessarily wrong, but I think for the most part we should kind of be on the same page. So what do you think we should do here first? What I would do first is I would distribute. And so as a result of distribution, I would have sine of x and then cotangent of x squared minus cotangent of x. And on the other side here, I would have cosine of x squared minus cosine of x. And the bottom stays the same for now. And my reason for that would be just distribution. Okay, so that's what I would have done first. All right, the next thing I would do is I would change everything into sine and cosine. So, cotangent. I'm going to replace that with sine squared over cosine squared. Notice they're squared because the cotangent was squared, so each piece ends up getting squared. Oh, I wrote that wrong, actually. Cotangent is not sine over cosine, it's cosine over sine, so actually I need to fix the one in the middle also. My bad. I'll go back and fix that. Okay, I'm going to go ahead and put these together now by multiplication. So I would have sine x is going to go on the top, right next to cosine of x squared. Got from there by multiplication, right? Okay, now what do you think we would do? So what I would do is I would reduce. I see that this sine x here can reduce one of the sine x's off the bottom and leave us with 1 now on the bottom. Okay? And so that's how I would handle that one. All right. Now, at this point, luckily, I already have a common denominator here. So I can actually just put these together now. And that should be the last step. At that point, they look like they are the same on the right and the left side. So I got from here to here just by combining fractions. And we're done. Okay. Let's go ahead and try another one here. Hopefully you guys are not just watching me do these, you're trying them on your own, okay? But you could watch these too to get an idea. You might have done it in a good way, but different. Just make sure that you're following good math rules and writing down good steps. All right, let's go ahead and take a look at number 3 here. All right, so for number 3, the first thing that I would do is I would just change everything to sine and cosine. So the first one would be 1 over cosine of x is squared. The bottom one would be sine of x squared over cosine of x squared. The one on the right side is fine already. Just like that. Okay, so my reason for that will be change to sine and cosine. Okay, next step, we want to simplify our complex fraction. So I'm going to multiply the top and the bottom by cosine of x squared. Okay. So in that case, these are going to cancel, and these are going to cancel, and I'll be left with 1 over sine of x squared equals 1 over sine of x squared. And I'll call this step simplify the complex fraction. Okay? Now maybe you called it multiplication. That's technically fine. It doesn't really matter what language you use so long as it accurately describes the step. Okay? Let's go ahead and take a look at number 4. Once again, go ahead and think about what you would do first here. Personally, I would change the cosecant into 1 over sine. And I would change the tangent into sine over cosine. And that would be changing everything to sine and cosine. All right, next step, multiply these together. Next thing, I would want to simplify my complex fraction. I'm going to multiply the top and the bottom by cosine of x. So here they cancel, and I will be left with cosine x over sine x is equal to the same thing over here. And now they match, and we can say that was simplifying a complex fraction. All right, let's go ahead and take a look at number 5. All right, now anytime I see an expression that is squared with a 1, it makes me wonder, is that a Pythagorean identity? And so at that point, I would turn my attention to my little list of identities, and I would see if that's one of our identities. And it turns out that this one is an identity. Cosecant squared x minus 1 has a Pythagorean identity, value of cotangent squared. I'll write it like this, though. So for that one, I'm just going to call it a Pythagorean identity. All right. After that, I'm going to go ahead and change everything to sin and cos. So this one's fine. I'll leave that alone. I'll write the square outside the parentheses, though. For the one on the bottom here, I'm going to rewrite that as cosine of x squared over sine of x squared. And the one on the right, I'm going to rewrite that as 1 over sine of x. Okay. What do you think we'll do next? Well, we have complex fractions, right? When you have fractions inside of fractions, we like to simplify those. So I'm going to multiply the top and the bottom of this one by sine of x squared. That way these cancel out. And on this side over here, I'm going to multiply the top and the bottom by just regular sine. That way these cancel out. And the end result will be as follows. We have cosine of x squared over cosine of x squared equals sine of x squared. Oh, I left this guy off over here. Let me fix that. I need to include that here. So we should have sine of x squared here. All right. There we go. And so what did I do there? I simplified the complex fraction. All right. Next step, these reduce. And that gets me to the end of the problem. So I have used my identities to prove that those are the same. And for that last step, I would just call that reducing for my explanation. Okay, and there it is. Let's go ahead and move along. Number 6. All right, once again, I see something as being squared here with a 1, and so I wonder to myself, is that a Pythagorean identity? And the answer is yes. That actually is equal to secant of x squared. This is weird. We don't see too many of those, but what that means is that's secant x to the 3rd power. All right, so that's a Pythagorean identity. All right, what's next? What do you guys think is next? Of course, it's changing everything to sin and cos. So this secant x to the 3rd power is going to be 1 over cosine of x to the 3rd power. Now you guys might be wondering, Mr. Bailey, why don't you put the 3rd power up here? Well, because 1 to the 3rd power is still just 1, right? So what's the point of putting that? I'll also do this one. All right. What should I do next? I'm going to multiply. I'm going to put these together by multiplication, and I'm going to end up with cosine of x over cosine of x cubed equals 1 over cosine of x squared. The last thing I'm going to do is I'm going to reduce, because I have 1 cosine of x on the top and 3 on the bottom. So this 1 on the top will take away 1 on the bottom and leave us with 2. And so now I have 1 over cosine of x squared equals 1 over cosine of x squared, and I got there by reducing. And we got our two sides equal. All right, moving along. Take a look at number 8. I see another square with a 1, and as one we saw earlier today, that is a cotangent squared. So I'm going to replace that with, I like to write it like this instead. Cotangent of x squared. All right. Guess what my next step is going to be? It's kind of been the same every time, right? It's going to be changing everything to sin and cos. So I'm going to have 1 over sinus x squared, 1 over cosine of x squared is equal to cosine of x squared over sine of x squared. All right, now what? Well, we have a complex fraction, so I'm going to multiply the top and the bottom of my complex fraction by cosine of x squared. These are going to cancel, and I'm going to be left with cosine of x squared over sine of x squared. Now, some of you guys might be wondering, should it be over 1? And the answer is, well, yeah, it is, but anytime you have something over 1, you really don't need to put the over 1. So I'm just going to write it like that. And we actually end up having the sides equal at that point. Or at least they look exactly the same, I should say. And that's what we wanted. So we got there by simplifying a complex fraction. And there it is. Moving along. All right. So here we are. I see another square with a 1, and I think, maybe that's a Pythagorean identity. But it turns out it actually isn't a Pythagorean identity. So what can we do here? Well, another possible route with this, before you just start turning everything to sine and cosine, and by the way, if you did that, you will arrive at the right answer eventually. We actually can do something else. It's factoring. This can be factored. We've talked about 3 factoring methods. There is the difference of squares method, there is the box method, and then there's the GCF method. Which one is that? It's the difference of squares method. So I can rewrite that expression as follows. The square root of tangent x squared is just tangent x, so I'm going to put that in the front. The square root of 1 is 1, so I'm going to put that in the back. We make one of them a plus, we make one of them a minus. You'll notice I skipped the step where I replace the tangent with the letter T and do it without the whole word. You can do that if it's helpful to you, but it's not necessary. Okay? So how did I get from here to here? You can just say factor. That's fine. We factored. Next, what do? Boom and boom. We reduce. And we now have our answer. We've got the two sides equal to each other. And we're good to go. Okay. Moving on to number 9. All right, so this is another factoring problem. Now you might be wondering, Mr. Bailey, how can I tell if it's a factoring problem? Well, here's what I would say. On every problem, I would say look for Pythagorean identities first. If you can't see a Pythagorean identity, then I'd say look for factoring. And if you can't find any factoring, I would say just go ahead and move right on into the sin and the cos. So, but for now, this one is factorable. Take a look at this top here. What method can we apply here? It's a GCF method. Both this expression here and this expression have something in common. they both have a secant x. And that's the GCF method. I can factor that secant of x out, and that would leave me with the following. So I got from here to here, once again, by factoring. That's good enough, but if you want to specify what method you used, you can. We use the GCF method. You don't have to do that, though. All right, next, what can we do? Well, we can reduce. All right. Now this one's a little bit harder to recognize because you see it a whole lot, but this is a Pythagorean identity. Look at your little Pythagorean worksheet. What does that equal? It equals 1. And I've got those two sides matching now. And that's a Pythagorean identity for the reason. And there you go. All right, so this one had factoring and Pythagorean identity in it, and we didn't need to change anything to sine and cosine. All right, let's move along. One more problem here for the day. What do you think we're going to do here? Well, I don't see any Pythagorean identities right now. Do we see any factoring? I see a trinomial. That one, I think I will take the time to go ahead and change it to just basic letters. So instead of sine squared minus sine minus 2, I'm going to put s squared minus s minus 2. And I'm going to do my box method. We know that we're right whenever these add up to make the middle, and they do. So I've got my answer. It's s minus 2 and s plus 1. Which means that we're going to call that sine of x minus 2 and sine of x plus 1. All right. So what we did there was we factored. Not surprising, the next step is just reduce, and we have our final answer. All right, guys, so that's the end of our Unit 12 test study guide. Kind of showed all the strategies. Once again, I recommend the way that you go through and do these is you start by looking for any Pythagorean identities first. After that, I would look to see if you could factor anything. After that, I would say just change everything to sin or cos. And then from there, you're just simplifying one way or another until the two sides match. So that's kind of the strategy we're going to go with to get these two sides to match and prove that these two sides are equal to each other. And that's it. So hopefully that was helpful. We'll see you guys in class. Till then, have a good one.